Okay, so we're talking about the graphs of radical functions, really just the square root, but okay, if I don't know what that graph looks like, how do I figure out what it looks like? Okay, yeah, how do we always figure out what graphs look like?
Oh, you do the XY thingy.
We plug some x values in, right?
Yeah.
So, what if I plugged in like -1 right here? What would happen?
It'd be 1.
What's square root of -1?
1.
0.
Nope.
Nothing.
Okay, it's not. This goes back to last Monday. It's not real.
Yes.
Why can't we have a square root of a negative?
Oh,
Because it doesn't work.
Yeah.
Okay, nothing times itself equals -1.
Yeah.
So we cannot use negatives over here. So does 0 have a square root?
Yes.
Yes.
1 and 4.
Okay.
Four.
2 and 3, these do have square roots. It's just that they are messy, right? Okay. So if I plug in 0, what do I get? 0. If I plug in 1, what do I get?
1.
If I plug in 2, what do I get?
Uh,
Okay, square root.
Square root of 2.
Says 4.
Square root of 2, if you plug in the calculator like what times itself, and you make it spit out a decimal, it's about 1.4. 1.4 times 1.4 is 1.96. So it's a little bit bigger than 1.4. Okay, square root of 3 is about 1.7. You'd have to get the calculator to get it more exact. But what's the square root of 4 though? 2.
Oh. How did you know?
Or -2.
I know that 17 squared is 289, so 1.7 squared is 2.89. So I knew it was close to that. Anyways, so 0, 0, 1, 1, 2, 1.4, 3, 1.7, 4, 2. Alright, can you guys tell what the shape is looking like?
A
It's
line.
like a zoom
Okay,
thingy.
what's another number? Let's go bigger. What's another number that has a nice square root?
No, it's not. 49. 49.
64.
8.
Okay, the next biggest number is 9, right?
Oh, that's
Because square root of 9 is 3. So 9, where's that at? 5, 6, 7, 8, 9. 3 would be a point also. Is that a straight line?
Yes.
No.
No.
I meant no.
It's a curve.
Bro,
Ish.
Okay. Does it go backwards? Why does it go backwards?
Because nothing times a negative. A negative times itself.
Because negatives don't work up here, right? So it starts at 0, 0, and it's not a straight line, is it? It's kind of leveling off.
Will it ever be a straight line?
No.
Okay, if I plugged in like square root of 100, what would I get?
10.
That means there's a point at 110. So you have to go all the way out to 100 just to get up to 10. It's like way over there, 100, and then it gets up to 10. You guys know what the square root of a million is?
I pretty much 100,000.
1,000. So it does keep 1,000. It does keep going up and up and up, but it goes slower and slower and slower. But it does go up forever. Okay, so let's see if you guys remember this. Do you remember what the domain means? So that's an ugly D.
Oh, yeah, it means that.
It means the possible x values. What x values are possible to use for this? Okay, can I use negatives?
No.
No. Can I use 0?
Yes.
Can I use all positives?
Yes.
Yes. So how do I describe that?
All real numbers.
Greater than or equal to 0.
So do you want us to like draw the graph?
All real numbers.
Okay, it doesn't include negatives, so that's not all real numbers.
Paxton, you're so funny.
Okay, does it ask for the range? I can't remember.
No, just the domain.
Okay, I'm gonna go ahead and talk about the range on this one. You guys know what the range would be for just this one?
0
Yeah.
to 9.
0 and goes forever up. Remember I talked about that? You could plug in square root of 1,000,000, that's 1,000. Square root of 1,000,000,000,000 is like 1,000,000. It does keep going up and up and up. It just goes really
Is the
slow.
range the y value?
So the range is y's
Oh.
are greater than or equal to 0. I think they're only going to ask us this today, but kind of a good idea to remember what range is. Okay,
Do you want us to draw the graph, or do you just want us to draw the thing on the left, the table of pairs?
well, number 1's not graphing, but number 9 is, and we'll come back to it once we get to number 9. Okay, number 9 is not graphing though. Number 9 is just what's the domain. So what did we just say the domain was for that?
0 is greater than or equal to 0.
X is greater than or equal to 0. Because under the radical, it has to be 0 or positive, right? So that's why the x's have to be 0 or positive. Okay, number 3. What do you guys think this, what do you guys think this -2 does to the graph? We've seen stuff like this before.
Doesn't it lower it since it's
It's
on
going to move the graph
outside?
down too. What possible x values can we use in here?
2.
Okay, anything that doesn't make the radical 0, right?
Yeah.
So again, we just can use x values greater than, this -2 does not affect what's under the radical, right?
Yeah.
This -2 is outside the square root. So we just need to make sure this is 0 or bigger. So the domain did not change. If I graphed it, it would just be down 2, so it would look like that. The domain, the x values though don't change. Alright, number 5. This time there is something under the radical. X minus 5.
Wouldn't that move it like the right?
Okay, here's the trick. Is everybody watching? Yeah, it does move the graph right 5. We need the x minus 5 to be at least 0. We need x minus 5 to be greater than or equal to 0, right? Because we can't have this be a negative because there's no square root of a negative. Nothing real anyway. So, how do I solve this for x?
Add 5.
Plus 5.
Oh. So then it'd be x is greater than or equal.
So the domain is x is greater than or equal to 5. You guys got it?
Yeah.
You just take what's under the radical and say this is greater than or equal to 0, and then solve for x. You guys know what the picture would look, we're not graphing it yet, but we're about to. You guys know what the picture would look like?
The same thing, just write 5.
Yeah. 1, 2, 3, 4, 5. Yeah. Right there, yeah.
So what, you see with like an x minus 5? What if it was like an x plus 5? Would you just like subtract it?
Same thing, yeah. Number 7. Okay. Do you guys know how I'm going to set up number 7? Yep.
Do it. Alright, so first thing I know is d equals an x. Okay, basically, so like you have to do that thing where you have to put the y equals and the square root x plus 2 minus 3, and then so x, you just like have to subtract the 2.
Okay. We just need this to be greater than or equal to 0. So it's
So
x
subtract
plus
the
2 greater than or equal to 0.
So they have to subtract the 2, and then x, yeah.
So does the stuff on
Okay.
the outside not really affect it?
It affects the graph. It does not affect the domain.
Okay.
It would affect the range because it'd move the graph up or down. So, do you guys know what this plus 2, this goes back to old stuff. Do you guys know what the plus 2 and minus 3 is going to do to the graph?
Up or left 2.
Left 2, because it's directly on the x, and down 3. So if I had to graph it, it would like start right here, and it would look kind of like that. Well, not that steep, but more like that. Alright, anyways, you guys got it?
Yeah.
So on number 8, how are we going to set that up?
On number 8,
8's trippy.
How are we going to set up number 8?
it's going to be negative 1x.
It's negative x or negative 1x greater than or equal to 0. How do we solve that for x though?
You divide by negative 1.
What happens when you divide by
The
negative?
sign switches.
Inequality switches. We should probably
Yes.
graph 16 together because it's different than the rest of them. Alright, anyway, we're to the graph. Number 9 is the basic y equals square root of x graph.
Wasn't that like the first one?
Yeah, that was my example at the beginning, you guys remember?
Yeah.
Let's use, how many points should we use?
Mr. Jordan, they're all the same. Section A is the exact same thing.
Yes, the first section, same as second section, but we just gotta do different stuff. Okay,
17.
let's do,
0, 4, 9.
okay,
and 6.
what are numbers that have nice square roots? Let's use those. 0,
4,
does 1
9.
work?
Yes, yes, yes.
Does 2 have a nice square root?
No.
No.
Does 3?
No.
Does 4?
Yes.
What was the next one?
9.
Right. When we go to do our graphs, since we kind of know what's going to happen, right? We really just need the first quadrant for number 9. Right?
Yeah.
Because where does it start at? 0. If I plug in 0 for x,
0.
0, 0. So that can save you some room on the graph paper. Square root of 1 is 1. Square root of 4 is, square root of 9 is, so 1, 1, 4, 2, 9, 0. You can do the decimals if you want to, it's just harder to make it look good. Let's see, 5, 6, 7, 8, 9. Missed a little bit.
How many do you want us to do?
Let's do 4 like this. 0, 1, 4, 9.
Wow, I got a real slowly.
Yeah, it starts off kind of steep and then it slows down really quickly. It's because the bigger the number you plug into the square root,
The farther you have to
the
go.
bigger the impact is the square root has on it. Like square root of 9 is 3, that was only dropping 6, but square root of 100 is 10, that's a 90 difference. So the more you plug in, the more it goes, makes a difference. Okay, anyways, number 11. Okay, on number 10, what would be some good, what's the smallest x value you can plug in? No.
It'd be negative 3.
Negative 3, because negative 3 plus 3 is 0, and that's the smallest we can do, right? So I would start with negative 3. What would be another good x value plug in?
Negative 7.
Okay.
Yeah, negative.
You kind of follow this pattern. So if you go one bigger, negative 2,
Yeah, it's not gonna help.
yeah, no, it does help. Negative 2 plus 3 is 1, and that actually has a square root. Now, the third number is 3 bigger, you see that? So what's 3 bigger than negative 2? 1. And if you plug in 1 right there, what happens? You get 1 plus 3 is 4.
Yeah.
And then the fourth number is 5 bigger, so 5 bigger than 1 is 6. And 6 plus 3 is 9, and 9 has a square root. So anyway, if you use those numbers, it'll actually have a square root on number 10 instead of these.
So then the x values will change, but the y's won't. If we try to get to the same numbers every time.
Well, not exactly. On that one it would, but on number
I'm
11,
tripped out right now, bro.
on number 11 it won't. You're just trying to.
5 minutes at a time.
You're just trying to find some numbers that when you plug them in actually have square roots.
Oh, okay.
So if you plug in -3, that'll make it 0 and
Where'd you get
0.
negative 3 from?
Negative, because it says +3.
Oh.
And -3 plus 3 is 0, and so that'll work. Now, why is 11 easier? Right.
Because the
There's
outside
nothing in the
doesn't-
square root besides the x. So we can use the same numbers because
No, that's crazy.
they still have a square root.
That's crazy.
Okay. But the -2 is going to change it a little bit. So square root of 0 is 0, -2 is -2. Square root of 1 is 1, -2. Square root of 4 is 2, -2. It's kind of like all the answers from 9, but 2 smaller is what's happening. And then square root of 9 is 3 -2. Okay, now do I just need the first quadrant here? No, not exactly, because it's starting at 0, -2.
So it's
Usually it'll go like 2 down.
that's crap.
1, -1. Yeah, the -2 is making the graph go down too, right? 4, 0. Alright, are you guys caught up? I don't know.
Yep.
I'm floating up to 13.
Man, dang it. Throw that all in number 10.
Okay, 13 is kind of like number 10 because it's got something in this radical inside the square root. So, what's the smallest thing I could plug in and it still works? What makes the square root 0? What could I put for x?
+5.
+5, right?
Yeah.
That's the smallest. 5 is the smallest thing that works. If I plug in 5, I'm going to get 0. Square root of 0 is 0. Okay. Normally, on the other two problems, we went from 0 to 1. On this one, we're going to move from 5 to
6.
6. Because 6 minus 5 is 1, and the square root of 1 is 1. Does 7 work well? No. 7 minus 5 is 2. That's not great. 8 minus 5 is 3. That's not great. 9 minus 5 is 4. And what's the square root of 4? 2. Okay. Last time, the biggest thing I plugged in was 9. But 9 minus 5, well,
You'd
alright.
have to use
Longer.
14.
Okay, I need something 5 bigger to make up for that, basically. 9
You'd have to
plus,
use 14.
yeah.
It's gonna be longer.
Yep. So this one is going to go way to the right. A 14 becomes a 9, square root of 9 becomes a 3.
So long.
So yeah, we need to make our x-axis really long this time. Starts at 5, 0.
Wow.
6, 1. 9, 2.
Wow. That's
Now, if you struggle finding the numbers that work well, you can plug in whatever and get decimals. It's just these numbers are easier to graph.
I think we're all watching Passion of the Christ. Oh, history. Oh.
Did you guys just get on a Bible?
Yeah.
Probably the bloody part hasn't started yet.
Nope. We just got to the part where like Jesus is, I don't know, there's a trials at night. Yeah, Bro, that movie is so good.
Gruesome. Alright, are we on 15? And then I said we're on.
No, we actually only have to go to 16. We only have to go to 16. Yeah, after 16, it stops.
Well, it stops graphing after 16. Yeah, after 16 it goes a lot faster. Okay, do you guys know what's the smallest x value I could use? Like what makes this 0?
-2.
X equals -2. When I plug in -2, I get -2 plus 2 is 0, square root of 0 is 0, but there's also -3, so 0 minus 3, -3.
Wow. Okay.
What's another good number?
-1.
-1. If I plug in -1, I get -1 plus 2 is 1, square root of 1 is 1, minus 3.
-2.
You know what I realized, Mr. Jordan?
Okay, and then the next one that I wanted was something, remember how we wanted it to be a 4?
Yeah.
Like, because 4s have square. So what x value would make this a 4?
2.
2.
Look me up red arrow.
2 plus 2 is 4. Square root of 4 is 2 minus 3,
1.
-1. And then remember how I wanted it to be a 9, because that has a square root. What x value would make this a 9? 7. So that'd be a good one. 7 plus 2 is 9, square root of 9 is 3, minus 3.
0.
Okay. Notice most of this is like below the x-axis. So you might need to draw it about like that.
Crap.
Because we're starting at -2, -3. This graph moved left 2, down 3.
I go only go 1, 2, 3, 4, 5, 6, 7. Yes, sir.
3, 4, 5.
They all look the exact same, but so different at the same time.
There are ways to make it look different. Kind of best.
Yeah, like on number C and E.
Now 16 is gonna look different. What do you think would happen if I put like a 2 right here, for
Then it
example?
would multiply by the square root.
It'd be twice as tall. Or if I put a 2 right there, this is like algebra 2 stuff.
Oh yeah, let's.
If you put a 2 right there, it would like squish this way. So it actually gets taller faster.
I don't like that.
But,
Oh, yes.
okay. 16, what's different about 16?
It has a negative x.
There's
it's
a
like-
negative on the x. Anybody want to guess what's going to happen with it? I don't know if we've talked about this before, maybe not. What's the smallest, what's a good place to start?
Plus.
Does 0 work?
No.
Negative
What's -0?
0.
0. What's square root of 0?
0.
Yeah, 0 works. Does 1 work? No, because that would be a -1.
Wouldn't it just?
So what do I need to use instead of +1?
Negative.
-1. Because -1 becomes +1 becomes square root of 1, which is 1.
Oh, so it'd just be the opposite.
Right.
Except 0 doesn't have.
I could plug in -2 and -3, but those don't, 2 and 3 don't have square roots. So
It'd be negative.
-4 and -9 would work well. So -4 becomes +4 becomes 2. -9 becomes +9 becomes 3. So what is happening to the graph here?
It's going like backwards.
Yeah, you might want to draw your axes like this instead.
That's crazy.
Because it's going 0, 0, -1, 1, -4, 2, -9, 3. Yeah. The x values flopped, so it's a horizontal flip. It's flipping right to left. That's what happens when you put a negative on the x.
That's crazy. to go below.
You would put a negative value in front of everything. I don't think they put that on this assignment.
What about number E though? Or letter E?
Okay,
On like 21.
21, yeah.
So would 21 be E?
Yeah.
Solid.
Okay, 17 through 22, these are pretty fast. They're just matching. Are you guys ready?
Yes.
Am I going too fast?
No.
Okay, 17. So it's just the basic square root of x. Which of those is basic?
A.
17a. 19. Let's move it over here. Okay, 19. What is the plus 2 right next
It takes it.
right next to the x? What's it going to do on
Take
19?
it to the left twice.
Right. When it's right on the x, it actually moves it left and right, and it does the opposite. So plus 2 on 19 moves it left 2.
E.
So that is D. 21. What does the... Okay, actually, 20 we just graphed, basically, right?
Yeah.
But 21 we did not graph. When you put a negative in front of everything, all the y values, it'd basically be what we graphed on number 9, but the y values would be negative, so it would go
Below.
upside down. So when you put a negative in front of everything, it just does that. So which one is that?
E.
E. When you put the negative directly on the x, like we did on 16, it was a horizontal flip, like it went right to left. Okay, 23. Write the function rule. Okay, if we want the function to go up 1, how do we make that happen?
If the f of x equals square root of x plus 1 on the outside.
Plus 1 on the outside.
Isn't that f of x also
Y.
It's the same thing as y equals. Just a different kind of notation. 25, we need to make it go 2 to the right and 2 down. How do I make it go 2 to the right?
Minus 2.
Minus 2.
Right.
Yeah. Put that up there. And then how do I make it go? You guys remember when I had this stuff like written over here, like
Yeah.
4 chapters ago?
No.
How do I make it go down to? Minus 2 on the outside. 27. Oh, reflection across the y-axis. So
What?
here's the y-axis, right?
Yeah.
So how do I make it go from this to this?
negative?
No.
Put a negative where?
On the inside.
On the inside. It's number 16.
Because it doesn't drop.
Reflection over the y-axis. So that's when we graph 16, you put a negative on the x.
Okay.
Are there any tricky ones? 28. How do we reflect it over the x-axis? Make it go from top to bottom?
Put the negative on the outside.
Yeah, it's like number 21. Put the negative on the outside.